lesson, 1-4, is about stem plots, you know. We kind of just saw one on the activity. A stem plot is this. There's two parts to it where there is a little stem which consists of everything but the final digit. You know, the stem in our one from the activity, the stems was like on the question that was asked, like the 4 in the number 40 was the stem. And the very last thing is called the leaf. That's just the final digits. The only thing about stem and leaf plots, which sometimes you hear me call that, sometimes you'll definitely hear me just call them a stem plot, is when you like make one, they have to be organized from like least to greatest and arranged vertically. So that's what we want to do. Even though we're going to let the technology do most of our graph making, I'm going to make a few by hand because I think we'll understand it. Off to the side here is a bunch of data about the resting heart rates of 26 ninth grade biology students. So the resting heart rate just means, you know, like after you've been sitting there for a while, like how your heart is beating and everything. So check it out. Here's what I want you all to do. Let's find the smallest number in the list. Can we find the smallest number in the list? And maybe just circle it. Who is the smallest? Some people's eyes are better than others. Help me out. Which one was the smallest? Yeah, that's cool. It's like, that's what I mean. It's like, it's not an easy thing to do. It's like when you think you find a small one, there's a smaller one. So 48 is the smallest. And then find the biggest. Who's the biggest? Got an 86. Is that right? Where the heck is he? I believe you. There's an 81. There's an 86. There's the big boy, right? You guys okay with that? So here's what we need to do. To make a stem and leaf plot, we've got to go numerically from smallest to biggest. So would you believe our smallest number is in the 40s? Are we okay with that? And our biggest number is in the 80s. And so let's start by just making a little vertical column like this. You can't skip any spaces either. Like, let's pretend there were no 60s or anything like that. You still got to put a representative for 60s. So the 4 stands for 40s, the 5 stands for 50s, the 6 for 60s, etc., all the way down to the 80s. All right, so there's our little stem. And let's go put in our leaves. This just takes a little bit of time. I know the smallest number on my list is 48, so are you cool with putting like an 8 right there for that being 48? Are there any other numbers in the 40s? Nope, so let's go looking through all our 50s, and we got to put them from smallest to largest. So let's see if there's any 50s. There's a 55 for sure, but hold on, I'm going to see if there's anything smaller than him. I don't believe so. Do you believe so? So 55. I like to cross them out when I'm done with them also. That's just my style. That's it in the 50s, right? Then go through your 60s. Is there a 60 straight up? Yeah, right here. All right, so I'm going to put a 0 right there for 60. And just keep going, right? Keep going. Get them all, you know. Why don't you pause the video and see what you can get. If you miss some here or there, that's why we'll do it in pencil and we can erase. The little leaves have to be from smallest to largest. So here's what my final stem and leaf chart look like. I'm going to count up all my leaves, right? And they better add up to how many total things were in there. The last thing we need to put on it, guys, is this thing down here called a key, right? So I need to label him also a key. Somewhere near the bottom, you need to tell people how to read your stem chart. So 4/8 like represents the number 48. Like sometimes 4/8 could represent like 480, you know, or like 48,000 or something like that. So you're just telling them how to read it. So it doesn't matter which numbers you use here, as long as like even if you did say like 5/2 equals 52, you know, it's like whatever you wanted to use, as long as you're telling them how you're to read it. You okay with that? Cool. Let's answer these questions. What % of ninth grade biology students have resting heart rates below 70 beats per minute? So they're asking for a %. I need to just count up how many people are below 70. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you see how, like all of these in here, there was 11 of those. We'll write down what we're doing. 11 out of, how many total were there? 26. Yeah. So we go punching that in to whatever calculator you want to use. 11 divided by 26. And that's a nasty boy. So we'll usually make this guy go to 3 decimal places, make him go to 3 decimal places. So wouldn't that be like about 0.423, about 0.423? So then we can make that a percent by moving this 2 decimal places and call that about 42.3%. That's how you round to the nearest tenth of a percent. You got to go to 3 decimal places in your plain Jane decimal. Cool. I'll let you discuss with your neighbor how to describe the shape of this distribution. If you want to turn your paper to the side so you can see it a little bit better, but is it like fairly symmetric? Is it skewed right, skewed left, that kind of stuff? So discuss. To say it could have either been roughly symmetric. You can put whichever one you want. Just put your answer, whatever you think. Roughly symmetric is fine. I think that's totally symmetric. Or, you know, like skewed left a little bit. I would have accepted either one of these. And I think that your homework program would have accepted either one of those either because it's that close, you know. It's that close. Cool. Which value appears to be an outlier? Do you think that any of these would appear to be an outlier? That's sort of a personal opinion until we can do the math behind it and figure out if there are any. Thoughts? Any outliers? No. I'm fine with an answer of no. The textbook said that 48 was an outlier, like 4/8 is possibly an outlier, you know, even though it didn't have a gap, you know, and it wasn't like way out there. Like if we were talking about everybody's heart rates, you know, and it's like, would you believe most people's resting heart rate was in the 60s and 70s, you know, and it's like, here's somebody at 48, they're like, that's a little low compared to everybody else. But if you put none, that's also correct, because we don't know mathematically how to determine if there's an outlier yet. But we will shortly this year, this semester. So if you put none, that's fine. If you put 48 or 4/8, it's all good in the neighborhood. Cool. There they made a stem plot for me. Ooh, just before we even read this, look at it. Something's different about this stem plot than the other one. What the heck is different there? They said that they split the stems. You know, you can kind of see that right here. Here's what that means. Like, how many times does this 8 show up? Doesn't the 8, according to this key, stand for like in the 80s, you know? But you see how it showed up 1, 2, 3, 4, 5 times. Same thing with the 9. It showed up 1, 2, 3, 4, 5 times. But the 7 didn't show up that many times because you see here in this group, like this column, you can put anything but like 0s and 1s in here. You can have 80 or 81s in here. In this row, you could have 82s or 83s. Here, 84s and 85s, and et cetera. Here's where 86s and 87s can go. Do you see how they like split it to where each one is like, okay, this is 80 through 81, this is 82 through 83, et cetera. They split the stems. Why do you think they did that? What would happen if they just had 7, 8, and 9 for like the stems? What would the graph look like? Discuss. What do you think that would look like? Go ahead. What would it look like? Yeah, unorganized is a decent phrase. You know, it's just like, because all the data like basically lies in the 8s and 9s. Are you with me on that? It's like you couldn't see a pattern to it because there's only like 2 columns, you know. It's just like 8s and 9s. So they split the stems to do this, you know. You can just kind of paraphrase this however you want. Because the data is so close together, let's just put that, you know. The data is so close together. That's all you can put if you really want to. If you want to write all this down, you can. But I think when all of your data set is just so close, it's in the 80s, 90s, you know, and that's it, it's probably a good idea to split the stems. So we get a better picture of the distribution. By the way, this data, since we kind of skipped over it, is about like the National Highway Traffic Safety Administration did a study of seatbelt use in all 50 states, and then like somebody was just observing at random on the highway, you know, like when they pulled somebody over or whatever, or if they even saw were they wearing their seatbelt or not, you know, and that's what this data is about. Would you believe that the minimum was like 76% of people were wearing seatbelts? You know, in today's day and age, a lot of people do wear seatbelts, you know. It's like they just know how much it saves lives and that stuff, so that's cool. In how many states was the seatbelt used to at least 95% of people in 2018? Well, first question is, does 95% count or not count when they say you've got to have at least 95%. Do you think he counts or doesn't count? He counts. If you've got at least, like let's say if in my wallet I had at least $20, then would you believe that I could actually have exactly $20 in here because that's the least amount I could have. So at least 95 means we got to count them all up. So there's 1, 2, 3, 4, 5, and 6. There are 6 of them, right? 6, since they want a percent, out of how many? Well, it looks like we probably got to count all the leaves, right? Oh, nope. Maybe they told us. Yeah, isn't there 50 states in there, right? So we don't have to count them all up because they told me. So 6 out of 50, and I'll let you change that to a percent. 6 out of 50. Yep, that's nice and exact. 0.12, which is 12%. Cool. So that's like the stem plot is just another way to organize data. What's so nice about it is everything's listed numerically, right? You know, just like in numerical order. And when the computer does it for you, that's real nice. Like we're going to have to do is just enter our data and it'll make it for us. So, cool. Let's go to the back side. The only last thing really is that they have a back-to-back stem plot. Where do you see, like, you've got your stems here in the middle, right? And then you've got 2 graphs at the same time. You've got this green side, where that's your normal dude. Please make a note of this other side right here. Everything here is backwards. Put that on to the side right there. It's backwards. The left side of a back-to-back stem plot is backwards. What I mean by that is if you see here in the 80s column, you know, like it goes 86, then 87. Like you got to kind of read it backwards. The numbers go like the smallest is on the inside and then it gets larger. So compare the distributions of seatbelt use in primary and secondary enforcement states. So here's what this happened. The primary enforcement was like, this is the first time that they got pulled over, you know, it's like the first time. The secondary is, oh, we've pulled you over before kind of thing. Let's see what happens on this. So when they say compare the distributions, your homework program is going to have it all set up for you. But that's that SOCV thing again, where we got to do shape, outliers, center, and variability. So let's start one at a time. And what I have done is I have kind of snipped these out so we can see them a little bit better. But let's label 2 categories. We got a primary and we got a secondary. So let's kind of label that in the little spots. And what we're going to do is we're going to do shape, outliers, variability, and all that cool stuff. So, but the primary graph is the one that's on the left side. You can turn your paper to be able to see it a little easier, but I turned mine to the side. And let's describe the shape of it. Here it is. There's the shape. Let's talk. Fairly symmetric. What do you think? Yes or no? I don't think so. Has it got some skew to it? Yep. Which way do you feel that it's skewed? I totally agree that that looks like it's skewed to the right. But this is backwards. Are you with me? Like, see how this is 9s, 8s, then 7s? Right? So when your brain says skewed right and you know it's a backwards graph, what is the real answer? Skewed to the left. Right? Skewed to the left. Skewed to the left, and then we'll put some other details, you know, like your homework program's going to ask how many peaks there are. Would you believe that that has like a single peak? You know, it's not double peaked or anything like that, so you can write that down. And your homework program is also going to ask for any gaps, right? And would you believe that there is a gap right here? We've just got to understand that, all right, that's like probably between 82 and 83 is what that's supposed to say, not 82 and 82. 82 and 83. Because here's 80 and 81. This one's 82, 83. This one's 84, 85. It's kind of like easier to see on the up and down guy instead. So I kind of did that one for you. Now let's go do the secondary offenses. Discuss with your neighbor, how do you feel this guy is shape-wise? Is he roughly symmetric? Is he skewed which way? Looking at this graph. Again, you could turn your paper to the side if you needed to. What do you think? I agree with roughly symmetric. Cool. Let's go and talk about peaks. How many peaks would this guy have? Single peak or double peak is how it'll be. So single peak. Are there any gaps in the graph? Yep, right here, right here. We just got to figure out where that's at. Is that 80, 81, 82, 83, 84, 85? Like, where's that guy at? Cool. So you can put all that stuff in. It is fairly symmetric. It's got a single peak, and it's got a gap between 80 and 81. Again, your homework program will have the drop-down menus like it normally does. We're just kind of writing it. So when they say compare the distributions, that's that whole SOCV thing from last time, where the S part of SOCV was described the shape. The next thing is your outliers. So let's do some outliers. Let's kind of go back to the first graph over here. Do you feel there's any outliers on this guy? Discuss with your neighbor. Any outliers? I personally would say yes to that, you know. What do you think about these? They just seem like they're a little out of the data. Right? So I'm going to put those. Possible, right? It's possible 78 and 80. Possible 78 and 80. It's possible. I would also probably accept that you're like, I don't really think that is an outlier, Mr. Fonistil. It doesn't seem like it's that far out, you know. For at this stage of the game where you don't know how to mathematically compute it, I'm cool with that. How about over on the other graph, the one on the right side? Do you think there's any outliers? Possible outliers. Probably maybe like right here, you know, maybe. I'm cool with that. If you also said no apparent outliers, I'm also cool with that because the graph is symmetric, you know. I did say that those were possible at 76 and 79. That's possible. So if you want to just put an O or, you know, like you just know this is category. So shape is the S in SOCV. O is outliers. The next is the C for the center of each graph. The center of each graph. Here's what we got to do. We got to count them up to see how many they are, unless they told us so. Did they tell us so? I don't think they did, because there's not as many in one graph as there is in the other. So let's count them up. Let's do this. Let's save time. Let's get the back half of the room counting how many leaves are in this graph, and let's get the front half of the room counting how many leaves are in this graph. Let's count them up. How many leaves did you get on this side, the one that's the backwards one? How many leaves? 36. I got 36, 35, 37, right? It's not an easy thing to count them up. I got 35 myself, you know. If you were off by one, it's probably not going to affect your answer too much. How about this other graph right here? How many leaves were there over here? What'd you get, Journal? 16? That's also what I got, you know, 16 leaves. So it's definitely not equal, you know, of how many there were, but they want us to find the center. Here's what you need to do. Grab ye old calculator if you need to, and just divide that by 2. So 35 divided by 2 to find the center of that would be the 18th one. You know, it's like that 17.5, so that means the 18th term would be the middle of this guy. Cool? Remember, on this graph, he's backwards, so I got to count backwards. I'm going to go find that 18th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, boom. There's the 18th guy. What number does that represent in that chart? 91, is that right? 91. So we can kind of do this. The center, you know, the center of this guy, we found him, is 91%, because those are all measured in percents. There were 16 of these guys, right? Who's going to be in the middle? Which term number? If there's 16 of those guys, which one's in the middle? It's going to be actually between the 8th and the 9th one, because it's an even amount. There is no true middle, so you go to the 8th, and then you've got to circle it with the 9th, and then we got to average those. So let's find the 8th and the 9th. So this one is in normal order. So here's 1, 2, 3, 4, 5, 6, 7, 8. Here's the 8th guy, if I can get my pen to work, and then the 9th guy right next to him. This happens a lot where it's the same number, right? So, but you would average those. 86 at 86, when you average them together, is it going to be 86 in that case? So would you believe that the center of that dude is at 86%? I did put the word median in there. I'm cool if you don't write that down today. You know, your homework program is going to have that, but the center is right there in the middle. Cool. And then variability is how far they spread, right? So let's do variability. Variability. And here's how we're going to probably start writing it. In this graph, who's the low boy? Who is the lowest one in the graph? 78%. And that'll go to the high boy. Who is the high boy? The highest one in this graph. It's this guy right here. Just how to know how to read, or whatever that is. Who is that? Is it 89 or is it 98? 98%. That's how they vary from low to high. It varies from 78% to 98%, which has a 20% difference, right? You know, there's 20%. Find the variability on the other graph. My bad, on the other graph. Just go low to high. Who's the low boy? Who's the high guy? And did you get from 76% to 92%? If you want to put their difference next to them, that might help you because the question's probably going to ask you which one varies more. Which one varies more, the primary or the secondary? Who's got the bigger variance? The primary one varies by 20%, and the secondary one varies by 16%. Which one varies more? Primary, right? Doesn't he have a bigger number? It's got a bigger variance. Cool. All right. Nice. So here's a couple of just little steps. They might ask you some homework questions about this, so like all the answers in the chart. It's just like, okay, if I was going to make a stem and leaf plot, how many stems am I supposed to use? You know, these are the stems. Like, how many stems do I need? There's no magic number. You just don't want to do too few or too many. You know, if you have too few stems or too many stems, it's going to be difficult to see the shape of the graph kind of thing. So try to use a decent amount. 5 stems is a pretty good, like, minimum. Like, if you're going to make a stem and leaf plot, 5 is a good starting number. You probably don't want more than, like, 10 or 12-ish, you know, kind of thing either. If you split the stems, make sure everything is equally distributed, you know. Like, you can't just have one split be, like, from 80 to 81, and the other one be from, like, 83 to 89. Make sure it's evenly balanced. And if you have too many digits, you can get more flexibility by rounding or truncating. So that leads us right into the very last problem where we might need to round some of these numbers off. Would you look at all of this data here? Chasing food for dollars. A marketing consultant observed 50 consecutive shoppers at a supermarket to find out how much each shopper spent at a store. So they were just standing like at the cash register. Geez, are you all right? Hey, like one thing I know we're learning me, but like if you want to sleep, you can go home kind of thing, right? So please, heads up, guys. Thank you very much. I appreciate it. If you don't want to be here, you don't have to be here. Go home. Okay. So 50 shoppers, they were just like totally just standing by the register, seeing how much they paid for their bill, and they recorded it. They did a very nice thing here by totally like putting these in numerical order for us. Or maybe Mr. Fonestill did that when he typed out this worksheet, you know, but I already put them in numerical order, save us a bunch of time. They want us to make a stem and leaf plot for it. So what's our very minimum dollar amount? $3. Like we're rounding to the nearest dollar. Okay, well, that's $3. And what's our biggest guy? Rounding to the nearest dollar, $93, right? So I got to go from basically $3 to $93. I want you to talk with your neighbor. What do you want to do for stems? What do you want to do for stems? Like what's the smallest stem? What's the biggest stem that you want? Like, how about this? Would that be cool to represent $93? So I need a stem for 90s. Then you would need a stem for what? 80s, 70s, 60s, 50s, all the way back, 40s, 30s, 20s, 10s. How the heck are you going to get $3 in there? Like what would be the first stem? Because I can't put it here because that would be $13, right? So what would I need to put up here for a stem? Oh, my bad. 0.3? Not going to put a decimal point. That's a good thought, though. Not going to put a decimal point. Like, what number would you want to put right here? I heard it. 0. Because if you put 0, 3 right here, doesn't that represent like no 10s and 3 1s in that case? So $3. I'll do a couple of stems with you, or a couple of leaves with you, and then turn you loose. This one, round him up, or round him to the nearest dollar. Is that $8 or $9? What would you put here? $8.88. Closer to $8 or $9? So I need $9 in there. What's this guy going to be? $9 or $10? $9. And then this guy would be 11. Okay. Does he stay in this category, or does he have to move down to the next stem to put 11? Doesn't he got to go down there? All right, so that's an 11. Just keep rolling, you know. Get that stem and leaf chart in there. Keep rolling. So I have mine done from the computer because I kind of misspoke. We were supposed to do it in the computer, but it looks like that. If you missed one here or there, totally understandable, you know. You just got to, that's why I do them in pencil, to go back and sneak those guys in. Then they say make another stem plot by splitting the stems. I'm not going to make us draw that by hand. I wasn't going to do that anyway. But when you have this in the computer, there is a drop-down menu that says, do you want to split the stems? So you could totally split the stems on that. So that's what it looks like if I split the stems, you know. This dude here goes from like, let me use a better one. This dude here goes from like 10 through 14. You know, that's 10 through 14, and this dude is 15 through 19 in that case. You know, so it just split it into 2 stems instead of like 5 stems as before. Which one do you think gives a better distribution of the data? This dude right here, let's just talk about the shape of him, versus this dude right here. Or are they equally as readable? You know, which one do you think is better to see the data on? Split or no split? If you had to read the data, what's your choice? What do you think? Split or no split? What are you choosing? There's no right answer to that. Split or no split? Which one do you like the best? I personally would choose the no split because the data is spread out. You know, it's like the data was spread all the way from 0 to 9 on the stem scale. There's 10 stems already. It's spread nice and even. It wasn't necessarily symmetric or anything like that, but it was spread. Here, all you did was spread it out even further, you know. So that's, you know, cool. All right, I will let you start the old